Hello and welcome to Nmap Fundamentals, the 11th video as part of our Red Team Fundamentals mini-series. In this video, we will be taking a look at how we can utilize Nmap to perform automated endpoint and service scanning. More specifically, we will be taking a look at how we can identify open ports on a given target, the services running on those ports, and several other techniques in which we can leverage Nmap to perform efficient network scanning. Now, as you will soon see, this part of Reconnaissance, and more specifically active reconnaissance, naturally flows into the complete coverage of networks from our passive reconnaissance series. One of the key points to note is that this form of reconnaissance often provides us with more context over the discovered information that passive reconnaissance might have revealed. And as per usual, everything we teach in this video is purely for educational purposes. We take no responsibility for your actions. My name is thoroughness, and if you enjoyed this video, please be sure to leave a like and feel free to join our Discord server, for which link to I've left down in the description below. Additionally, we are releasing a Red Team Initial Access course this week at no cost whatsoever. It covers modern phishing techniques, means for foothold onto a system, and more. For more information about it, you can find it in our Discord server. So then, picking up where we left off, in our previous several videos, we have been discussing passive reconnaissance techniques. More specifically, we explored the concept of OSINT and implemented it across several key domains, including networks, websites, people, files, etc. Now, one of the main things you might have noticed is that the information discovered during the passive reconnaissance stage might have been outdated, inaccurate, or simply irrelevant. Active reconnaissance, in this case, takes it a step further and involves directly engaging with the target organization and its assets in order to find out the information we are seeking. Now, this interaction can take various forms, some including port scanning, which involves directly interacting with the ports on a target system and fingerprinting them to find out their applications and versions. Other forms of interaction can occur through brute forcing, where we leverage dictionaries, or otherwise known as word lists, in hope that through repetitive scanning, we can identify pre-computed information that may simply be hidden. Essentially, any technique that involves direct interaction with the target constitutes active reconnaissance. It allows us to gather more relevant and detailed information, enriching the data that may have already been collected through manual OSINT techniques. Now, although active reconnaissance is more informative than its counterpart, the price that we pay for such intelligence comes at the cost of our exposure. Now, more specifically, the main disadvantage of active reconnaissance is that our activities are visible to defenders. This should be pretty evident, as after all, we are generating traffic to interact with the target in scope. And as you recall, this was not the case with OSINT techniques, as we leverage publicly known information. Now, there are of course certain OPSEC considerations that we can take into account. However, to avoid confusion, we will leave that for a separate video. Now, in this video specifically, we will be taking a look at a specific active reconnaissance technique known as port scanning. Port scanning fundamentally enumerates open or listening ports of a given target. Now, if you've never heard of what a port is, essentially it is a communication endpoint that provides a virtual point where network communications start and end. Every port will typically be associated with a specific process or service, where through that port, all interactions will take place. Now, the ports that are utilized will depend on their transport protocols. There are two in total, including Transmission Control Protocol, or TCP, and User Datagram Protocol, or UDP. And the main differences are in how communication is handled, where TCP is connection-oriented, and UDP being connectionless. However, the main thing that we should be concerned about from a Red Team perspective, that is that each of these transport protocols may be serving different services. Thus, we should always ensure we are enumerating across the two. It's a common mistake that is made, and especially between beginners, but it often leads to missed data that can otherwise prove highly useful. As it should hopefully be clear by now, by enumerating open ports of a given target, we can identify the services that are running on the target system. However, those ports may also provide their service versions and other critical network information, such as host names, domains, network shares, and more. This is precisely why port scanning is really important. That being said, let's now take a look at Nmap and how we can leverage it for service identification. Now, surprisingly, a lot of beginners tend to think that because Nmap is such an old tool, and I believe it was developed back in the late 90s, is that Nmap is not really capable of modern network scanning. Now, of course, there are modern, port scanning tools, but you've got to remember that networks have fundamentally stayed the same. Now, although different ports and protocols may have undergone numerous upgrades, so has Nmap. So Nmap is still a very strong tool for its capabilities in network scanning. Now, Nmap typically comes pre-installed on Kali Linux and other distributions such as Parrot, so you won't really need to install it if you are running one of those. So if you actually go into our console, run the Nmap command with the version switch, you should see that Nmap will print its output along with the version information. Now in this case we are running Nmap version 7.98, but we will also install it from scratch. Now before we actually clone and install Nmap, I quickly want to show you its documentation. Now Nmap has a large documentation, both virtual and physical. It actually features a whole book as well, which I have, and I can definitely vouch for it being very comprehensive. I've not fully read the complete book. One of my colleagues actually got it for me, but it's very informative in case you do want to learn more about Nmap. Now what I'm going to show you here is the reference guide, and essentially it is a online documentation of Nmap, and you can browse all of its features here. So I've had a look here, port scanning basics. It explains that there are numerous port states within Nmap. You get open, you get closed, filtered. So it's a really handy guide when you are learning about Nmap, and I would suggest that you take a look at this reference. That being said, to actually install Nmap, it is pretty straightforward. All we need to do is simply clone the repository here. So we're going to use git clone. And once that's cloning, the configure command here will prepare the build environment, make will compile the build, and then make install will copy the compiled files into their final destination. Now we can run all of these at once here. So if we cd into the nmaps directory here, run the configure command, use the $& symbol to essentially execute a command once the previous command finishes. So we'll provide make here, and then finally make install. And once that's done, you should see a installation message essentially saying that Nmap has successfully installed. And to ensure that everything has installed correctly, we can simply run Nmap with the version switch again, and you will see here that we are running the same version as we have done prior. Now then, to actually initiate a scan, all that we need to do is provide the Nmap command, and then we'll also be providing a target asset. And this target asset can be as you can see, a host name, an IP address, or even subnet. But just be sure that if you are indeed scanning remote hosts or scanning remote websites, that you have permissions to do so beforehand. web1.corp8.cloud is a local Windows server, so obviously we have permission over our own local network. So by pressing enter here, the scan will initiate, and shortly after, as there we go, we should see our results displayed back to us. Now you will typically see 3 columns. You've got the port column, which essentially outlines all of the identified ports. You also got the state column, which specifies whether the port is open, closed, or maybe even being dropped by a firewall. And then additionally, you also have the service column. And essentially what this specifies is the specific service for the identified port. Now, although this is great, and it provides us with more information than passive reconnaissance might have provided, there's just this one thing that we need to discuss before we discuss any switches. And that is that, by default, in a unprivileged context, Nmap will perform what is known as a TCP Connect scan. And essentially what a TCP Connect scan is the establishment of a 3-way TCP handshake between the client and the target server. So to illustrate this better, what I'm going to do is I'm actually going to open up Wireshark here, and by looking at the packets, I'll be able to describe this a little better. Now we are running our scans on the ETH1 interface. So if I actually showcase you here with one single port, let's just say port 80, and you'll understand this piece switch shortly, but essentially it allows us to specify the ports we are scanning. And if we click enter here, you'll see that these scans initiate. Now, if we take a look at the filters here, you'll see that by providing TCP, we can identify the specific TCP connection that was initiated. Now, in this case, when we are performing privilege scans, as is the case from our root session, what we are performing is what is known as a TCP SYN scan. Now, I know all of this terminology can sound different, But if we take a look at the privileged context here, you'll see that in order for the scan to complete, the client here or the source sends a SYN packet to the destination. And essentially what this specifies is, hey, look, are you running on that port? And what the target then sends back is a SYN ACK packet. And essentially what this specifies is that, it acknowledges that communication that was established by the client. And by using this TCP SYN scan, we can essentially identify an open port simply by doing half of the handshake. Now, this is different for TCP Connect scans, and to initiate a TCP Connect scan, we use the ST switch. Now, as I said, this is the default when you are running in a non-privileged context. So to showcase you what I mean here, I'm going to refresh the scan here, continue with the TCP filter there, press enter. You'll see here that our new results will be displayed. Now, if we stop this, you'll see here now the handshake is much more comprehensive. So from our client, we send to the destination SYN packet, and then the target host responds with a SYN ACK. And then from our client, again, we send back an ACK packet. And this is the key difference here, by the way. And then only then we close the connection. Now, the problem is with a TCP Connect scan is that, in order to identify that open port, we must establish a complete three-way handshake. And now this is not the case if we are using a SYN scan, which again is default. And you can actually specify a SYN scan using the S and uppercase S switch. But essentially a SYN scan allows us to perform half of the handshake, and thus it is a bit more stealthier and covert. So just always remember, when you can, use a TCP SYN scan. And when you can't, when you've not got the privileged context, which would be a bit weird if you haven't, just be mindful that you are establishing a complete three-way TCP handshake. Now, in order to obviously understand what I've just described, you do need to understand a little bit of networking, but the whole principle is that, TCP SYN scans are more stealthier. Hopefully I've not confused you too much there. Now, one of the issues with the scan that we just performed is that the scan fundamentally only enumerates TCP ports. And in the world of networking, many different services might be running on UDP. And some of these services, might include stuff like DNS. Kerberos actually uses UDP as well. And to always ensure that we are executing comprehensive scans or scans for UDP ports, we can also provide the SU switch. Now, one of the issues with a basic UDP scan is that a scan of such can take quite a long time. Now, this is mainly because UDP is a stateless protocol. Now, what this means is that it does not acknowledge received packets as TCP does. So essentially, there is no way to determine whether those packets are hitting nothing, encountering a firewall, or simply reaching a service that does not respond meaningfully. Now, to avoid scanning the default top 1000 ports, I'll simply use the top port switch to specify the value of 10. And what this will do is essentially scan only the top 10 most common ports. And the reason I'm doing this is to avoid the long waiting times that UDP scans can take. So if we provide web1.corp.a.cloud again, and then once the scan is complete, you can see that it only took 3 seconds, and it would have actually taken a lot longer if it was 1000 ports. But by looking at the results here, we can see that we have SNMP open. We also have NetBIOS, and then several others here, but most of them are closed. Now, in the cases where we are being as comprehensive as we can actually scan for TCP ports and UDP ports sequentially. And to do this, we simply need to provide the Nmap command, of course, the SU switch to scan for UDP ports, and then either the ST switch for TCP Connect scans or the SS switch for SYN scans. And what this will do is essentially scan across all of the port range for both TCP and UDP ports. Now, I'll actually use the top port switch again with a value of 100 to avoid scanning 1000 common ports. And then obviously comes the hostname corp.a.cloud. And whilst it's doing so, I quickly want to show you one useful feature. Now, if we click enter here, you'll see that Nmap provides a status update on our scan. And as you can see here, we can see the amount of time that elapsed for our scan. You can also see the number of hosts that completed the scan, if we did provide a subnet, that is. And then another useful identifier is the about section here. And essentially what this specifies is the percentage of how much the scan is completed, and also how much in seconds is remaining for the scan to complete. And it's pretty useful, and in the situations that you are running long scans, simply by pressing enter you can reveal how much of that scan was completed. Now if we take a look at the output here, obviously we'll see some UDP ports here, UDP port 137, 161, and then also we've got TCP ports such as HTTP, we got SMB, we also got HTTPS, and by combining a UDP and TCP scan, we can just simply scan across TCP ports and UDP ports both at the same time. Now then, one of the issues of using scans this way, in the way that we used earlier, is that Nmap will only perform the scans on the top 1000 ports, the top 1000 most common ports by default. Now, it's useful and it is good for quick identification of the most common type of services on a given system. However, just note that that is not really comprehensive, and it does not provide us with the complete picture of the open services or open ports of the given target. Now, when we're operating with ports, whether we are operating with specific ports or ports within a given range, which we'll discuss shortly, we simply use the P-switch. And the P-switch, accepts numerous different values. The most common value that is used is simply another dash here, and what this specifies is that to scan all of the given ports on a target. So rather than scanning the top 1000 ports, this option will specify that Nmap should scan all of the ports instead. So naturally, this will take longer, but then we'll see a larger surface area in terms of what services the target is running. Now, once complete, as you can see here, there are numerous more different services identified. Now, most of these services will belong to Windows, but 2 of these services here are of particular interest. Now, although not really that informative over the type of service that might be hosted on that specific port, we can nonetheless identify that there are numerous different ports that are open on a given target by performing a complete port scan. Now, we'll get into shortly what these 2 given ports are, but this is a very common configuration that enterprises or organizations implement. And as I said earlier, this is what is known as security through obscurity. And as you'll see soon, the service running on port 7331 will be a service known as Jenkins, and then on port 2222 will be SSH. Now, don't worry too much about it now. We'll get into how to identify them better shortly. Now, as I said earlier, the P-switch does accept numerous different values. We can simply provide the ports that we want to search specifically by comma separating them. So in this case, we specify port 80 and port 443, and what this will do is only scan those specific ports. So as you can see here, Nmap returned the results for the ports that we were interested in, and by using this we can reduce our network traffic that we generate to the target, and thus stay more under the radar. Now, another way we can use this is simply by using a range, and to specify a range we simply use any sort of port from the port we want to scan from, and then a dash and the ports up to which we want to scan to. So in this case, we are going to provide 1023, and this will scan the entire well-known port range. And as you can see here, we get a little bit of less results, but then we've only scanned for a given set of ports within a range. And this is really useful, when you don't want to scan any ports that might be non-standard. So as we saw earlier, those ports within the 49,000 range were pretty much useless to us. So just remember, when using the P-switch, you can specify a dash to scan all ports. You can also specify a set of comma separated port values to scan the specific set of ports. You can also just specify one port if you want to as well. And then if you want to, you can also specify a range of ports by simply using a dash. Now, as we saw when performing UDP scans, and especially when performing version detection of services, which we shall discuss shortly, scans can consume a considerable amount of time. Furthermore, certain scenarios may require adjusting our connection frequency for enhanced stealth. Hence, it is crucial to understand how to strike an effective balance between speed and stealth in our scanning operations. Now, Nmap operates on things called timing templates, where each template offers a different balance between speed and stealth. And as you can see in the table that I've made, there are 6 total templates, each ranging from maximum evasiveness to maximum speed. So the first mode there, in the first row, is the mode that is called paranoid, and this specific mode is designed for IDS evasion. Now, it is the most slowest and most conservative, and typically transmits 1 probe or packet in this case at a time, typically with a delay of 5 minutes between them. Now, trying to scan an entire port range of 65,000 ports will take you just about 5,000 hours, which is 7.5 months. Therefore, use this scanning option really when you only have a handful of ports you want to scan while staying as evasive as possible. Trying to scan 65,000 ports is simply unreasonable with this option. The second mode, which is called sneaky, comes with a value of 1 and is typically faster than paranoid and dispatches each probe with a delay of 15 seconds between them. So much faster, but still relatively slow. The third mode, which is called polite with a value of 2, is significantly faster than the former 2, as each probe is instead transmitted in small groups, each with a 1 second delay between them. The fourth mode, which is called normal, comes with a value of 3 and is the default option. And essentially it provides an optimal balance between stealth and speed amongst all of the available templates. The fifth mode, which is called aggressive with a value of 4, is used when stealth is not important and when scanning a large number of hosts within a short time frame. And the probes that are sent out within this mode are transmitted in the range of milliseconds. Lastly, the final mode, which is called insane, comes with a value of 5 and is the fastest option that Nmap supports. Now, probes are typically transmitted with no inter-probe latency, and using such template during real-world assessments is highly discouraged because, as you may imagine, it can trigger excessive alarms and exhaust system network resources. Overall, the default or normal mode is typically best in all case scenarios. However, your requirements may differ, and thus you will need to take those into account when deciding the timing template to use. Now then, to implement a timing template, we simply use a T-switch and then we provide it any of those modes that we previously discussed. So in this case, using a mode of 1, which is sneaky, we'll perform a scan where every single probe is dispatched within a delay of 15 seconds. So if we provide our target here, web1.corp.a.clouds, and actually open up Wireshark here, continue without saving, run it again. And if we observe the network traffic, you can see here the first packet that is dispatched, or the first probe that is dispatched for port 3306. And then shortly after 15 seconds that is, comes another packet for port 587. As you can see, this type of scan is significantly slower, but when we do have a handful of ports, say maybe, I don't know, T1 with a value of top ports, maybe 10 or 15, this can actually be really useful because the traffic that it does generate will be much less or lesser. So I suggest that you experiment with timing templates and try to observe the network traffic and how frequently that network traffic is generated. Now, as we saw earlier, some of the identified ports might have been a little bit confusing in terms of the services that they may have been running. So if we take a look here, the service running on port 7331 is running service SWX, and I believe this is the Swiss exchange service. I could be totally wrong, but then we've also got port 2222, which is supposedly running Easy Engine. Now, as you can see, I'm confused and you're probably confused as well, because we're not actually getting any contextual information about what that service might be running. And this is very common, when performing basic port scanning, because if we take a look at this file here, Nmap uses this specific file for default port to service mappings. So essentially, Nmap goes through this file, takes a look at port, let's say 2222, and basically identifies Easy Engine without performing any additional service identification. Now, this can be quite troublesome because we don't actually get any contextual information about the services that are provided back to us. And to actually fix this, we can use Nmap's service probe database, which essentially contains a collection of probes for querying those various discovered services along with matching expressions to recognize and pass their responses. Now, what this means is that for every identified port or service, Nmap will additionally dispatch a set of specific queries to that service. And by doing so, the specific service will respond with a given value of its own, and thus we can identify the specific service that is actually running there. Now, don't worry too much about this. Just note that we can implement this through the SV switch. So if we use the SV switch here, but you can write some of these probe queries yourself, but we won't do it in this video because it's quite confusing, or it's a little bit complex to understand at first. Now, we can actually connect manually to a specific service, and the way we do so is by using the NC command. And the NC command is basically netcat, and it can actually help us identify a specific banner of a service. So all that NC requires is a specific address, or IP address or hostname. So if we provide web1.corp.a.cloud, and then it will also need a specific value for the port that it's going to connect to. So if we specify port 2222 here and connect to it, you'll see here that it might appear that the connection hangs, but actually if we just press enter here, or some sort of string here, you'll shortly see that the service will respond with its own banner. Here we go. So what the service basically responded is that, it got invalid SSH identification string. Now, this is because we manually connected to the service and basically sent some junk output. So the service wasn't able to actually pass that output correctly. But if you take a look here, we have a banner, or we have the specific fingerprint of that service. So essentially the service responded with the specific banner of it by simply us sending some junk data to it. So this is really useful, but it's typically quite tedious to perform on every single identified service. And also keep in mind that it might not be the same, or not all services might respond with such information. But by using the SV switch with Nmap, we can simply identify the given services automatically. That is, if Nmap identifies the service with its database of probes. So as you can see here, once done, Nmap does indeed return the correct service for that specific port. And additionally, it does so the same with port 7331, which is actually running a HTTP server. Now we can actually control the thoroughness of version detection by using the version, I think it's in 10 city switch. And essentially what this allows for is the specification of a number between 1 and 9 of the intensity to apply for a specific port. So essentially how hard Nmap should try to identify the service for that specific port. And this is done by simply Nmap sending more probes to that given service. So to specify maximum intensity, we can use the value of 9, but just keep in mind that from an OPSEC perspective, this might not be the best, because we generate significantly more traffic. But by simply selecting enter here, the scan will begin again. But as you can see, we pretty much got the same information as we've gotten earlier. But just note that in case Nmap does fail to identify a given service, you can simply use the version intensity switch to increase the intensity for which Nmap attempts to identify the given service. Now, before we actually wrap up, let's just quickly discuss several more scanning options that we can implement. Now, one of those options is Nmap's aggressive scanning. And what this specifies is for Nmap to perform numerous additional checks for the identified service. Now, it performs checks such as operating system detection, and you can actually specify this manually using the O switch. It also performs a traceroute check, and again, you can manually specify this using the traceroute option. And additionally, it performs version detection, so SV. And additionally, it also performs default script scanning, which we'll get into in the next video. Simply put, the A switch allows us to gain the most comprehensive information about a given service. And from an OPSEC perspective, as you can imagine, this is not really that great. But nonetheless, let's just implement this and observe the results that we get. So web1 corp.a.cloud selecting enter here, the scan will begin, and just keep in mind that it can take significantly more time to complete. Now, the results took a while to complete. I mean, if we take a look at the scan status here, you'll see that we started our scan just around 10 minutes ago. But if we take a look at the data that is provided, it is a lot more comprehensive than what we've seen earlier. If we take a look here, specifically, some of these scans incorporated various different options. For instance, we've got the HTTP server header option. We've also got the HTTP title option, and additionally, we got HTTP robots. Now, these are not options per se. Actually, these are what are known as scripts. And again, we'll get into scripts shortly, but by utilizing numerous of Nmap's provided scripts, we can essentially perform a lot more enumeration over the identified services. So as you can see here, by leveraging the A switch, we managed to get a lot more information about our target. And this might prove useful for when we are conducting phishing attacks. As if we take a look here, we actually even get the hostname of the target. And one of the last options that we are going to discuss is the V-switch. And the V-switch essentially specifies the verbosity level of what our scans should produce. Now, this verbosity can be controlled by any value between 1 to 3, or additional V's, to match the value of 1, 2, 3. But essentially, when we use this switch, if we click enter here, you'll see that numerous more information is provided to us during our scans. As you can see here, we can see the identified ports at the time we are running our scan. We can also see some DNS information and much more information that might be relevant to what you're trying to establish. So again, you can use any value between 1 to 3, so 2, 3 like so. And then that will control the amount of verbosity that your scan produces. And that will do it for Nmap fundamentals. So we've basically covered the most fundamental switches or options that Nmap supports. And in the next video, we will be taking a look at Nmap scripting engine to essentially elevate our Nmap scanning. We'll take a look at how to identify vulnerabilities. We'll take a closer look at what scripts are, and that will complete our Nmap short mini series, and then we'll proceed on to Nessus, which will allow us to identify those vulnerabilities even more. So I hope you've enjoyed the video. Again, feel free to join our Discord server, and you'll find a new course coming out this week. So we hope you really enjoy it, and I will see you in the next one.